This is lesson 4-7, congruent and overlapping triangles. Now we're not going to learn any new rules for proving triangles congruent, but what's going to happen in this lesson is that we're going to have triangles that overlap, so it's a little bit harder to see what's going to be congruent because they are overlapping. So overlapping triangles may have a common side or angle. You can simplify your work with overlapping triangles by separating and redrawing them. Okay, or if you want to try and highlight them, that's another way that you can do this, but we're going to separate them and redraw them. So the first problem we have here is we want to identify the common parts. What common angle do triangle ACD, okay, so this triangle on the left right here, ACD, and triangle ECB share? So we want to separate and draw triangle ACD. So ACD is a triangle on the left. We're going to draw that. And we're going to draw a triangle ECB, which is a triangle on the right. And as you can see, they both share common angle C, so the common angle is going to be angle C. So sometimes overlapping triangles might share an angle, a side, or even part of a side. As you can see that BC in triangle ECB is also part of side AC, which is in the other triangle. So it can get a little bit complicated. Let's use common parts to prove things. So in this particular problem, we have triangle ZXW is congruent to angle ZXW is congruent to angle YWX, and angle ZWX is congruent to angle YXW. So the triangles right here are drawn re-separated. So as I can see, WZX, and I have this angle X right here. That was that first one, angle ZXW, is congruent to angle YWX, which is over here. So basically this little corner of the one triangle is congruent to the little corner of the other. When they were together, that little corner was part of also the big angle of the other triangle. So that's where it gets a little complicated. I want to prove that ZW, which is this side right here, is congruent to YX, which is this side. Now I can't prove any sides or angles congruent without first proving the triangles are congruent. Remember, that was the CPCTC. So first I want to show, the plan is I want to show that triangle ZWX is congruent to triangle YXW. Then I'm going to use the corresponding parts of congruent triangles to prove that ZW is congruent to YX. So let's look at what we have so far. So far we have this angle here, angle X, or it was referred to as ZXW when it was overlapping because I needed to use the three letters to identify it, is congruent to this angle. So this angle, I have two angles, this one and this one congruent, and then I have this one, angle W, and angle X over here congruent to each other. So I have two angles, I need a side. Look at the picture and see if there's any sides that I should know. There's nothing in the given, but is there something that's shared that I can use? Okay, and then we're going to try this flow proof right here. So we're going to write this proof as a flow proof. I have angle ZWX congruent to angle YXW. Okay, and I have the other angle, angle ZXW, congruent to angle YWX. But they share that side. They share WX, so it has to be the same length in both triangles. So WX is congruent to WX. And remember, when something's congruent to itself, that's the reflexive property. So I have my two angles which were given. I have my side which is shared. So now I can say the triangles are congruent by angle side angle. So triangle ZWX is congruent to triangle WXY by angle side angle. And then I can say once my triangles are congruent, all those corresponding parts are congruent. So I wanted to prove that ZW is congruent to YX, and that would just be by CPCTC. Okay, so that's the overlapping triangles, and we will work with those again tomorrow.